Hello friends, welcome back to channel Civil Engineering Academy. Today we are going to learn about a dumpy level. Dumpy level. A dumpy level is a simple and the commonly used instrument in the surveying, and it is used to measure the horizontal levels and to find the differences in the height between the 2 points on the ground. This instrument has a telescope fixed firmly on its support, so it does not move up and down or sideways. And because of this fixed arrangement, it is called as a dumpy level. Dumpy means what? It's a short and the strong. Dumpy level is mainly used in the construction work, road and railways project, leveling land for the buildings and the irrigation projects. The dumpy level is strong, easy to use and gives accurate result in the leveling work. There are many advantages of a dumpy level. We will start with the accuracy point. A dumpy level can measure the height differences very accurately, and it is more reliable than the simple hand levels or the spirit levels. Then the next advantage is it is a strong and durable. Its body is a compact, short and the strong as the name dumpy level, and it can handle the rough usage on the construction site and still give stable results. Then adjustment point of view, it needed less adjustment. Once the instrument is properly adjusted, it remains stable for a long time. Unlike the some instrument, it does not require the frequent recalibration in the field, so it is a very easy to handle on site. Then the next is the telescope is rigidly fixed to its support, so it ensures that the line of a sight does not move or the shake, giving consistent readings. Then the next advantage is its a cost. It is a low in cost compared to the advanced instrument like a theodolite, auto levels or the total session. A dumpy level is a cheaper, and it is a suitable for the small and the medium projects with limited budget. Then the next advantage is it is simple in the use. With the basic training, even beginners can learn to set it up and take the readings. It is widely used in the education and the small construction projects. The next advantage is it is reliable for the long projects. It is especially useful for the long linear projects like road, railways, pipelines or the canals. Once the instrument is set up, it can cover long distance with the accuracy. So these are few advantages of dumpy level. Now we will move to the disadvantages of a dumpy level. Then the first disadvantage is considering the time consumption. Setting up the instrument, centering the bubble and taking the multiple readings takes a lot of time. Compared to the auto levels or the digital level, it is slower. So it consumes lot time as compared to the other advanced instrument. The next disadvantage is it needs manual calculations. All readings have to be written in the field book and reduced levels must be calculated manually, and this increases the chances of a calculation mistake. The next disadvantage is limited functions. A dumpy level can only measure the horizontal levels and height differences, and it cannot measure the vertical angles, horizontal angles or the direct distances. The next is skilled staff required. At least 2 people are needed, one for handling the instrument and one for holding the staff. The staff person must keep the staff vertical, otherwise the error occur. Then next disadvantage is mistakes may happen in the staff reading, bubbling, centering or in the field book recording. Even a small error can affect the accuracy of a final result. So this is a major disadvantage of a dumpy level. The next disadvantage is not suitable for the modern large projects. In today's big projects, speed and the multiple functions are the required, and auto level, digital level and the total session are the faster and more versatile, so dumpy level are becoming less common. So these are the few disadvantages of a dumpy level. Now we will see how dumpy level works, means step by step procedure how it works. In the dumpy level, first of all we have to choose a benchmark. In short, we can say the BM. We have to pick a firm point with known reduced level. Then we have to set up a tripod, keep the legs wide and the sable on the firm ground and head roughly level and at a comfortable eye height. Now fix it on the tripod and screw it firmly and don't over tighten it. Use the tripod legs to make the instrument approximately level. By using the 3-foot screws, we have to keep the telescope parallel to any 2 screws and turn those 2 together either inward or the outward to center the bubble. Then turn the instrument 90 degrees and use the 3rd screw to center again. Then repeat until the circular bubble stays centered in the direction. The next thing, we have to focus eyepiece. Then aim at the sky or keep the white paper in front of this eyepiece and rotate the eyepiece until the crosshairs are sharp. Then focus on the objective. Aim the staff. Focus until the staff graduations are the sharp. Then the first reading taken as a backside reading and take this on the benchmark and ask the staff person to hold the staff vertical. That means the bubble on the staff does not wave and it is at the center only. Then note the backside reading in your field book. Then compute the HI with the known RL because height of the instrument is equals to reduced level plus backside reading, that is the first reading. Then take the intermediate side reading. Then cite other the required points from the same setup. Then reduced level is equals to HI minus intermediate side readings. Then record each reduced level in the similar manner. Then select a change point and take a foresight. The last reading on that instrument session is considered to be foresight reading. Then the next thing is select a change point, that is CP, and take a foresight reading. Choose a solid, easy to recite point. Then take a FS on the change point. This will be your last reading before moving to the instrument and record it. Then shift the instrument, move the dumpy level to the next position, keep the distance similar to the reduced error. The next step is shift the instrument, move the dumpy level to the next position and level is again as told in the previous steps. Then the take backside reading on the same change point and the first reading from the new setup is a BS on the change point. Compute the new HI, that is reduced level plus backside reading. Then continue leveling, take IS on the required points and take FS on the next change point before each move. Repeat until you reach the final point or benchmark. The next thing we have to do is close and check. If possible, close on a known reduced level, that is original benchmark or another known point. Then we can check it arithmetically, like summation of a backside reading minus summation of a foresight reading is equals to last reduced level minus first RL. So if it is equals, then it is balanced and otherwise there may be error. And if it is balances, your work is good and accurate. This is the sample field book by HI method. There are the two different methods, that is HI method and rise and fall method. So this is nothing but the sample of the field book where we can mark as a sessions backside reading, intermediate side reading, foresight reading, height of instrument, then reduce level and the remarks whenever required. Then in this table we have to enter the first reading on the first session as a benchmark reading. We have to enter this on the back side. Remember, the first reading on the instrument session is always a backside reading and the last reading on the instrument session is known as a foresight reading. And all the other readings in between the backside reading and the foresight readings are entered in the intermediate side readings as shown in the table. Then we calculate the height of the instrument is equals to the known reduced level plus the backside reading, and we calculate the reduced level of all other points. Then we do the change points, and on every change point the first reading is entered in the backside reading and the last reading before changing to the another point will take that reading as a foresight reading. And in between the backside reading and foresight reading will take all the readings as a intermediate side readings. So this is the calculations to find out the reduced level. Then after calculating the reduced level of all the points, there is arithmetic check whether the readings are taken accurately or not. For that, we know that the summation of a backside reading minus summation of a foresight reading is equals to last reduced level minus first reduced level, and if the values come same, then work done in the accurate manner. Next is quick tips for the better accuracy. Keep the backside and the foresight distances roughly equal to cancel the instrument errors. The next is avoid very long sights, that is greater than 30 to 50 meter when high accuracy is needed. Then ensure the staff is vertical. Then recheck the bubble before every reading and record the readings to 3 decimals. Also, write remarks clearly and avoid the heat shimmer and strong wind if possible. So, this is all about the dumpy level, starting from its introduction to step by step procedure and the advantages and the disadvantages. Even though the modern instruments like auto level and the total sessions are the widely used, today the dumpy level still holds the great importance in learning the basics of surveying because it is simple, reliable, and accurate. I hope this video helped you to understand the concept clearly. Keep practicing and your confidence in the leveling will definitely improve. Thank you so much for watching video till end. If you like the content of video, please like it, share and subscribe the channel.